In the previous video, we saw techniques for machining the core of this mold. Let's go back and just do a quick back plot here and take a look exactly at what we were doing. This was a core roughing toolpath that machined its way from the outside of the boundary to the inside of the part, therefore eliminating the direct plunges into the material. Let's now go ahead and machine the cavity for this mold. In my file, if I go into my level manager, I can turn my cavity on and my core off. Roll this over, and you can see there's the cavity for that mold. To show how easy it is to change the parameters for surface high-speed toolpaths from part to part, I'm just going to take this initial operation, drag it down, and copy it. I need to go in and reselect my geometry and change a few parameters. First thing that I'm going to do is change the planes. I'm not machining from the top. Now I'm machining from the bottom. I go into my toolpath type, and I'm not going to be core roughing, cutting from the outside in. I'm going to be doing an area clearance, cutting from the inside out of a cavity. Select area clearance. I need to reselect my geometry, unselect all, and then reselect. Go into my solid selection dialog, and I'm going to select this entire body here. I'm going to go into my steep, shallow parameters here and redetect the limits. This means that the shallowest cut will be placed at 0, 0, the top of my stock, and the deepest cut will be placed at minus 1.5. This will in effect limit my cutting passes to within the cavity, so there will be no air passes above and no passes below. Also click OK and regenerate. Let's go ahead and backplot that. And the cutting strategy we can see for area clearance is entering at the center of the part. I have helical entry set here, and machining from the inside out. Let's go ahead with one final check, and we'll verify this operation. And that's exactly what we expected. Here we have the cavity of a mold, which is the ideal shape for a high-speed area clearance toolpath. We'll start by going under Toolpaths, Surface High Speed, and then select Drive Surfaces. Now I have a solid model on screen here, so I need to go into Solid Selection mode, and then I'm going to select the entire body. Now even though we're not going to be cutting the sides or the bottom of this part, obviously, the quickest and safest way when programming these surface toolpaths is just grab the entire part. That way Mastercam sees the entire model and won't violate any of the surfaces, whether we're cutting them or not. End selection. OK. And then for a toolpath type, area clearance, which we can see cuts from the inside out from this small graphic here. Tool, I'm going to pick a 3/8 bullnose end mill. And then for cut parameters, climb cutting, my step down here. And by default, this goes to 37 thousandths. I'm going to turn this up a little bit to 1/16 of an inch. Now, I'm going to turn on the add cuts, which will prevent steep stair steps at the bottom of our part and take progressively shallower cuts where the slope tapers off. We'll be able to see this and verify very nicely. My minimum step down, I'll leave that at 10 thousandths. In my maximum profile, I'm going to tighten this up a bit too. We'll say 80 thousandths. Turn on corner rounding to smooth the toolpath motion out. And then my step over, I'm going to reduce this a little bit to 35%. Since we're cutting a cavity, and chip evacuation might be a bit of a problem. And then my stock to leave on walls and floors. Let's tighten this up a bit to 20 thousandths on both the walls and the floors. Now after I set this stock to leave value, I like to go right over to the arc filter tolerance page, because this is very important in relation to stock to leave. There's an entire video lesson on total tolerance and its uses and applications, but in a nutshell here, we always want our total tolerance to be about half of our stock to leave. So 10 thousandths, this will create a much smaller NC file. And then we'll go into steep shallow here. I just want to make sure that I'm cutting in the model and I'm not facing the top or anything inadvertently. So I'm going to turn Z depths on, and then I'm not sure what the exact height of this part is, so I'm going to use the quick entry method by right-clicking and then Z coordinate of a point. I'm going to select the very top of the part here. That happens to be Z.5. And I'm just going to subtract minus 0.001 1/1000th of an inch. Now what this does is this is forcing the tool not to take anything above that, in which case that will eliminate cutting any of the top face there. Then my maximum depth, once again, right-click, Z coordinate, and I'm really not concerned about my maximum depth. I just want to make sure it can go all the way down as far as it needs to. I'm just going to click the absolute bottom of the part here. And then one more page here, the transition, is very important for the area clearance toolpath. Since this toolpath is always plunging into material, we need to be very careful and aware of how it's getting into that material. Now it can either helix or ramp in. Now I'm going to select helix for this option, and I'm going to tighten up the radius a little bit to 1/8 of an inch. So we'll click that to feed rate. Now if for some reason the helix fails, if the tool is too big and it cannot do the helix, it will automatically go into the ramp mode here, and it will ramp at 2-degree angle. Alright, let's leave the other parameters and see what this toolpath looks like. And then if we backplot, and zoom in a bit here and study the toolpath, I have my arc motions in my backplot turned to orange and linear moves are blue. So you can see nice arc motions in the corner here, and also the full helix is an arc. Now we can go ahead and verify this. And we're taking 16th inch step downs all the way through. But then if we zoom into the bottom here, we can see our add cuts feature kick in. Now what that's allowing, where the slope tapers off and it's a very shallow angle, the 16th inch step down could leave a pretty large stair there and uneven material at the bottom of the part. So add cuts is activated automatically and adds a few extra Z passes there to leave us with a much more consistent remainder of material. Now you'll notice that only the center cavity has been cleaned out, and our two pockets have not been machined at all. Well, that's because our 3/8 tool could not fit into there. So we need to create another op and just target it to those two smaller holes. But what I'm going to do is create a containment boundary just to keep it in those two holes and not let it machine anywhere else in the part. So to create those containment boundaries, first thing I'm going to do is switch colors. I'd like to select a contrasting color, so we'll pick orange. And to create those boundaries, since this is just a solid and there's no wireframe anywhere, I'm going to create a curve. Create curve on one edge. I'm prompted to select a surface, pick that upper ridge, and then this one here. Okay. And now we can see I have two nice arcs, which will be my containment boundaries. Pick up this first operation, right-click, and copy after into the parameters. Then we're going to leave it as an area clearance. However, now we need to set up our containment boundaries. So we'll go out and select them. That one and that one there. You can see those are added here. Then for a tool, we need something smaller than that 3/8. Let's try this 3/16. Then down to our cut parameters, step down 18 thousandths. We'll turn that up a little bit. We'll say 25. The minimum step down, we'll leave that at 2.5 thou. Then the max profile. I like to set this just a little bit above the step down. So let's say 35. Then our XY step over, We'll reduce this a bit here, 30%. Then our stock to leave on walls and stock to leave on floors. I'm going to tighten this up since we're using a small tool and there's going to be subsequent small tools going into those features. We'll say 10 thousandths. Then go right to my arc filter tolerance page. Make sure this is going to be half of stock to leave. So 5 thousandths. Then our steep shallow here. Now since we have a containment boundary, that's going to effectively limit the tool to a certain region. So I don't need to limit the tool using the steep shallow or Z depths. So a good point to take away from this lesson is the two main methods for limiting the regions machined by the high-speed toolpaths. And that's either using Z depths, such as our first example, or containment boundaries for this particular toolpath. And then regenerate, backplot, and then we'll verify. That looks pretty good. Once again, we have our main step down here, up top, and then they get progressively shallower, so we get a much closer representation of the final shape of this part. Let's now take a look at using surface high-speed toolpaths for rest milling operations. Here I have this part roughed out using a surface high-speed core roughing operation with a 3/4 inch bullnose end mill. Let's go ahead and verify that and take a look at what we've got. There's our completed roughed part. The steeper areas look pretty good. This outer area and these steeper tapered bosses. However, these shallower tapered bosses have some pretty pronounced stair-stepping on them, and also this center area between these bosses, that 3/4 inch tool could not fit into, so there's a whole section here that's unmachined. I'm also going to save this as an STL file so we can verify from it for future operations. I'm going to save it as core rough and exit out. Now to create the rest milling operation, I'm just going to right-click, drag, copy after, collapse my roughing operation, and go in and start to change some parameters here. Now I leave the toolpath type the exact same of what I had before, drive surfaces and containment boundary. However, my tool, I'm going to switch that to a 1/2 inch bullnose end mill. I go into my cut parameters, and my step down for the previous operation was 75 thousandths of an inch. The default for a 1/2 inch tool here, Mastercam's telling me 50 thousandths might be a good value. However, I'm going to make that 25 thou, a little bit finer finish. To create a rest milling operation, all I have to do is turn on this rest passes feature and also enter my roughing tool diameter, which was 3/4 of an inch, and the corner radius, which was 30 thou. Let's go ahead now and regenerate. Now, rest milling passes take a little longer to regenerate because it has to refer to the previous operation and calculate how much material to remove. So I'm going to pause the video here for a moment while this regenerates, then resume after it's finished. Okay, let's now backplot that and take a look at what we've got here. Okay, that looks pretty good. However, it's machining passes on this outer area, which I certainly don't want or need. And also, it's doing a little bit too much work on this fillet here, this large outer fillet. Now, there's a couple different ways we can limit the motion. I could either set a containment boundary and have it keep inside that boundary, or I can limit it to certain Z depths. I'm going to go into my parameters here, steep, shallow, turn on use Z depths, and I'm going to type in the question mark. I'm prompted to select the coordinate of a point for my minimum depth. Now this is going to be the uppermost cut level. I go back to my screen. I'm going to select the top of this boss here, and the value is filled in there. For the maximum depth, I'm going to enter Z, enter. Again, I return to my screen to select a Z level. I'm going to select the floor of this. OK. And now let's regenerate again and see what we've got. OK, let's backplot that now. That looks pretty good. However, it still just takes one pass around the perimeter. Let's leave that for now. Go into Verify and see what things look like. I'm going to select that STL file I created as my stock. Okay, that looks pretty good. I'm going to zoom in a bit here. And we can see that those bosses got machined, and this area in here certainly got cleared out. I'd now like to try and eliminate that final pass around the perimeter. We'll exit out, go back, and change my Z depths a little bit more. Now my stock to leave was 10,000ths of an inch, which we can see if we go into the cut parameters, stock to leave 10,000ths of an inch. And when I selected my maximum depth, I selected the floor of the model. The actual stock left is 10 thou more than that. We'll regenerate that, back plot. That looks like a little bit better of an operation now. We'll do a verify one final time here. You can see I got some better clean out in the center here, and I eliminated that outer pass. Exit out, and a few other things to know about rest milling with surface high-speed toolpaths. This is not tied to this previous operation like in traditional Mastercam surface rest milling. It's its own toolpath, so if we change any parameters in the first operation, it won't affect anything in this rest milling operation. In other words, these two are not linked together in any way. The only thing that denotes that this is a rest milling operation is this toggle here, the rest passes. Here's where we left our part with our core roughing toolpath. Let's now work on some rest milling ops to get this closer to size for some finishing. Now there's several ways to work with rest milling operations, one of which involves a CAD file. And that CAD file is going to be in the form of an STL. What we have to do, however, is save our roughed model here in Verify as an STL file. So I'm in Verify, this is completed, and then I go to Save Stock as File. Now it's important to keep in mind where this file is saved and don't lose it. I usually just let it go into the default location. Save, then exit. Okay, now we're ready to do some rest roughing. What I'm going to do is copy this operation here, right click, hold the button down, drag it after, copy after. We'll go into the parameters, toolpath type, switch it out to a rest roughing, and we have all of our surfaces and faces maintained since we copied it. Now for a tool, let's try this 5/16 bullnose end mill, and then cut parameters. We want to climb cut, and then very important here, this little button use core mill passes. What this will do is cut with our core mill style toolpath, cutting from the outside in. We got a 30-second step down. Let's bump that up a little bit to 50 thou maybe. Have our add cuts on. Minimum step down, we turn this up a bit, 10,000ths of an inch, and turn down the maximum profile a bit. My stock to leave, I'm still going to have 20 thou there. And then go right into my arc filter, double check that this is half of what my stock to leave is, which it is, 10,000ths. And then rest material. Okay, this is where all the action happens with the rest milling operation. We have 4 different ways of how this op can interrogate our file and see what material is left. We have all previous operations, one other operation, a roughing tool, or a CAD file. So we just saved that verify as an STL file. So I'm going to select CAD file here for this first example. Click OK, and then when I hit regenerate, it will tell me operation does not have an STL. So I need to go out into my geometry, select CAD file here, and then go and pick up my CAD file that I saved, that STL. And it's giving me a little preview of what material is left. We can see this big fillet down here. It's superimposing that STL on top of my original part. And now I can regenerate. And then we'll backplot. And see that tool just nicely going after my outstanding boss. Once again, with very good arc motion and a smooth tool path. And we'll go into a verify, and we'll start from where our roughing left off. And there's a good rest milled part, ready for some finishing ops. For the tool paths that use constant Z cutting, those are core roughing, area clearance, and waterline finish. We have the ability now with surface high-speed machining to use adaptive step-down. Those constant Z cutting tool paths tend to work very well in steeper portions of your part, as 30 to 90 degree walls. However, when you get into more shallow areas, they tend to leave very large stair steps. Let's take a look at machining this part with an area clearance tool path. I go into my parameters. We can see I have 1/8 of an inch step down, and my adaptive add cuts feature is turned off. We'll go ahead and verify that. And my part here has step down passes equal to 1/8 of an inch. On the vertical areas of my part, that finish may be okay. However, shallow areas, such as this very shallow fillet down here, I get very large stair steps, which leaves a little bit too much to clean up. If we go ahead and backplot this tool path, turn my shading to translucent, and we'll look at it from a side view here. You can see that each step is equally 1/8 of an inch apart. Let's go ahead now and take a look at the adaptive step downs. Here I'm going to select the Add Cuts button, and the values that I have keyed in here allow my tool to make a minimum step down of 25 thousandths of an inch. So my step down will be between the range of 0.125 and 0.025. Let's go ahead and regenerate that and verify. And you can see here I have a much more consistent profile of my stock here, especially in the shallower areas where Mastercam configured a shallower step down for me. We can go into backplot here with a side view, and we can see that my tool is taking a large step down in the steeper areas, but as it gets down to the shallow areas of the floor of my pocket, the tool is taking progressively smaller step down. So how does it configure what size step down to take? Well, it always tries to take the largest step down possible. But if we go into our parameters once again and take a look at the max profile step over, this value here is the width of the stair step left on my part, while taking a step down somewhere between 0.125 and 0.025. Now, the stair step may get larger because it cannot take a step down any smaller than 0.025. So for example, let's reduce this value to 5 thousandths of an inch. Click OK and regenerate. Let's go and verify. these stair steps here are even smaller than the previous verify, because now our value is 5/1000ths of an inch stair step, whereas the last stair step size was 16/1000ths. So even up on the steeper walls of my part, Mastercam forced a very shallow step overs to maintain that 5/1000 stair step value. We can see that in the back plot, side view again, and throughout just about the entire part we took very shallow step downs. That's because our value here of our max profile was 5/1000ths of an inch. Let's go the other way now and change this value to 50/1000ths of an inch. Regenerate, and now we'll back plot again. You can see now this is taking the full 125 step down at the top of the part, but then in the bottom here moves down to the shallower step down value. Go ahead and verify that, and we can see the result. So in summary, by having add cuts selected and using the adaptive step down values, you can create a happy medium between large step downs for aggressive cuts on steeper areas of your part, and then minimum step over and the profile of your stair steps to create a finer roughed part in these shallower areas. In this video, we will start to look at the finishing toolpaths for surface high speed, in particular finishing the horizontal areas of this model. I have this model roughed out using a surface high speed core roughing with a 3/4 inch bullnose tool. Then I perform a rest milling operation with a 1/2 inch bullnose tool. Now I'd like to start finishing my model by using the surface high speed finish horizontal. What I'm going to do, I'm going to right click, drag this toolpath down, copy it into my finishing group. Let's collapse the roughing group. Then we can see my geometry and containment boundary from the previous operation follow right into this toolpath. For toolpath type, go to finishing and horizontal area. I'd like to select a tool. I'm going to use this 3/8 inch flat end mill. As I select a new tool and operation, Mastercam fills in the default parameters based on the tool selected. So here I have 2 depth cuts, 50/1000 step down. It also calculates my XY step over and has optimized cut order selected. Let's go ahead now and backplot this toolpath and see what the defaults look like. I need to regen, and now let's backplot. Mastercam uses a pocket style cutting routine, and for the top of the bosses you can see it uses a pocket facing style. It is typical high-speed machining with minimal retracts and very smooth entry and exit into the part. You can also see that it nicely contained itself in the constrained areas in between the bosses and faced the top of the bosses completely. Let's go ahead now and verify and see what this looks like. I'm going to select a file for my stock source, and the file is my previously roughed operation. And there we have the model finished. Now you can see my tool didn't quite fit in between these 2 bosses here. Let's go ahead and change tools and see if we can get this to clean up a little bit more. So we will exit out of verify, go under my parameters, tool, and let's create a new tool. Be an end mill, 5/16 in diameter, and it will be flat. Okay, and regenerate that, and we'll go into verify again. And it looks like I had much better cleanup in between the tight areas of my model here. However, there still are a few things that I'd like to change. Let's go back and re-verify this model, and we're going to focus on the top of these taller bosses here. Reset it. And now I'm going to slow this down a little bit, and watch how it cuts the boss from the center and with a nice helical entry. However, it leaves a rather tall and sharp rim around it before it completely faces it. Let's go ahead and zoom in and continue to verify. And it's doing that in 2 passes. Let's stop the verify there. Go back into my parameters, and that parameter is going to be the XY step over. If I increase this step over to 65%, OK, and regenerate, and we'll go again once again and verify. And we can see that the increased step over, it's cutting more from the outside inward. Go ahead and slow that down a little and continue to verify. I think that's going to be a little bit smoother of a machining operation. Continue it, and we'll zoom out and double check our model. Now, as we can see here from the yellow areas, the horizontal finish operation only touched the horizontal areas of my part. Even if you have a slight slope, this operation will not see it. It must be a true horizontal area. Here I have a part with flats at various Z depths. This is an ideal part to be finished with the surface high-speed horizontal. We'll create that op from scratch by going under Toolpaths, Surface High Speed, and I'm prompted to select Drive Surface. Now, as always with my Surface High Speed toolpaths, I select the entire model as a drive surface. Switch to Solid Selection, turn off Select Face, and just have Select Body on. Click my entire model, End Selection. I've got 328 faces. All I want to do is machine the internal flats, the top of this boss, and the various floor depths. I could add a containment boundary, which would be the profile of this bow tie shape, but I don't have any wireframe here, so I'm going to use the settings in the toolpath to force the tool just in the cavity of the part. Select a finishing toolpath, and then horizontal area. Move down to the tool. I'm going to pick a 3/16 flat end mill, and then into the cut parameters. And I can climb or conventional. Of course, we'll leave this on climb. Specify the number of depth cuts. I'll just take 1 here. Then move down to my stock to leave on walls and floors. I'm going to machine this to size, so we'll toggle on 0 there. Take a look at my step over, 45 thousandths. That seems adequate. Check my transitions. Now this is how the tool enters the material. I prefer helix, and we'll tighten up the radius a bit to 1/8 of an inch. And I want it to enter at the feed rate, not the plunge rate. Then check my linking parameters. And I like this set to minimum distance with a feed rate of my fastest feed rate my machine tool will accept, which I know is 500 inches a minute. And we'll go ahead and leave all the other defaults and take a look at what we've got thus far. Now right off you'll notice the first problem we have, the tool is machining the top of the part. We certainly don't want that because that's going to be faced with a regular facing tool. Then the tool goes in, finishes all the flats, top of that boss, and each floor. You'll notice that it's using a nice helix motion to get into each pass. So let's go in and make one quick adjustment to keep the tool off the top and just inside our part. Go into the parameters. Now we could add a containment boundary. This would certainly work, but I don't have any curves there. I could either create those curves, which would take a couple minutes, or much easier, go into my steep shallow parameters. Now I'm just going to force the tool to cut between the depths of just a little bit below the top of the part and then all the way down. So turn on my use Z depths. Now I have no idea what the Z depths of this part is. So what I'm going to do is use the shortcut entry method of right-clicking in the field and then select Z coordinate of a point here. Takes me back to the screen. And I'm going to select the very top of the part, which happens to be Z0. I'm just going to subtract, we'll say 2/1000ths. And then for my maximum depth, same thing, right-click, Z coordinate of a point, and then select the bottom of the part. This ensures that I'll have everything between 2/1000ths below the surface and then all the way down to the floor. And then we'll run a back plot. And we can see with that one quick adjustment, depth limiting, we're kept off the top of the part and just machine all the internal flats. Very handy, quick and easy toolpath to use.